Sasrika students, let's have a talk on masaledar topic, perpendicular bisector of an angle. Students, the question is, this is an angle. Let's say the name of the angle is ABC. Now, it's any angle. What is the perpendicular bisector of this angle? Well, students, the answer is, it's a stupid question. The perpendicular bisector of an angle just doesn't exist. Really? Yes. We can talk about bisector of an angle. What's that? See students, the red line is the bisector of this angle. This is not bisector, this is not bisector. This is a bisector of the angle which actually divides this angle into two angles, angle 1 and angle 2. But there is no concept of perpendicular bisector of an angle, just like we talk about perpendicular bisector of a line. You see students, we have a line AB, all right. We can draw the bisector of the line. This is the center point of the line. Any line which passes through the center point of AB is the bisector of this line. Let's say this point is O, but now this line becomes perpendicular bisector, which when apart from what? Apart from bisecting this line, it also makes 90-degree with the line. Now, this is the line. Let's say the line is CD. Line CD is a perpendicular bisector of AB at point O, because a line can make 90-degree with another line, but this line, let's say BX, cannot make 90-degree with the angle ABC, and that's the reason the perpendicular bisector is not possible. It's imaginary. It's stupid also, you could say that. Now guys, there are other things, some interesting things about angles, you know, and triangles. So let's see whether you enjoy that. Now let's say students, I have a triangle. Now this triangle you can see is a scalene triangle, you know, almost, you know, these two sides are a little different. It's a scaling triangle, right? Or maybe I really make it scaling triangle by like this. I put it like here, maybe like this. Yes, and then it becomes a. It's definitely a scaling triangle, right? It's a scaling triangle now. So, guys, what I want to say is that, let's say the name of the triangle is A, B, C. Now, can I draw a bisector of angle A? Yes, I can draw bisector of angle A. How? Well, bisector of angle A is this. Once again, bisector of angle A is this. I can say AL is the bisector of angle A, which is dividing angle A into two equal parts. Right. Now, what is the concept about perpendicular bisector here? Perpendicular bisector of angle, as we have already learned, is not possible. But perpendicular bisector from A can be drawn on BC. Once again, perpendicular bisector from A can be drawn on BC. Perpendicular bisector from any vertex can be drawn on the opposite side. Can it be drawn always? Let's see. Yes. Yes. So perpendicular bisector from point A, can it be drawn in a scaling triangle? The answer is not exactly. If I draw, you see, if I make this perpendicular, let's say this point is AL is perpendicular to BC. It is perpendicular, but it's not dividing BC into two equal parts. So it's not really possible to draw perpendicular bisector from A to side BC. When it is possible? It is possible, students, when this line AC becomes equal to AB. Wow, that's interesting. That means the concept of perpendicular bisector is possible only in case of isosceles triangle. I take pardon in case my spelling are right, but it's not an English class, don't worry. So now the question is it possible perpendicular bisector only in isosceles triangle? No. The answer is it's possible even in equiangular triangle, or I say equilateral triangle. This is my equilateral triangle. Here I can draw perpendicular bisector from, let's say this vertex is A to the opposite side. Beautiful. It doesn't only make what 90 degree with the opposite side, but also divides the opposite side, let's say BC, into two equal parts. All right, guys. Now, the last question. As we have seen, in a scaling triangle, it's possible to draw bisectors. It's possible to draw bisectors. This is a scaling triangle. Let's say this is a scaling triangle. It's possible to draw bisector of this angle, bisector of this angle, and bisector of this angle. But all these lines will never meet at one point, which is the case when all these lines will meet at one point. And what is that point known, students? That point is centroid. And that is possible only in case of equilateral triangle, where my bisector, perpendicular bisector, all are aligned, all are coincident, they are all matching. Let's see. So this is the, what do you say, perpendicular bisector from A. This is the perpendicular bisector from B, and this is the perpendicular bisector from C. Very interesting, students. All these perpendicular bisectors, as you can see, they divide the opposite sides into equal parts, and at the same time they make 90 degree, with the opposite side. Not only that, these perpendicular bisectors are there, and they also divide the angles also into two equal parts. Interesting. The angles are also divided into two equal parts. All the opposite sides to the angles are also divided into two equal parts. And all these perpendicular bisectors are also meeting at a point known as G, the centroid of a triangle. Now guys, in this case, this perpendicular bisector is known as median. And all these medians meet at point G. And one more interesting thing about medians, they all get divided at point G in the ratio 2:1. Not only that, all the medians divide the triangle into two equal parts. So guys, we end up listening, we end up understanding that perpendicular bisector of an angle is not possible. So all questions don't have answers. All the best.